Hey everyone, it's a pleasure to be here. Thank you for the introduction, Kisu. And today I'm very excited to kind of come to you and speak about first-class Auth experiences, specifically in front-end applications. And I want to kind of put a little highlight on mastering access control. Now, access control is extremely important, and you're going to find out throughout this presentation and this slideshow why it should be important and how we come to really, really understand it. Now, as Kisu said, he gave me a great introduction. My name is Filip Grebowski. I'm a developer advocate at Permit.io, a YouTuber. Some of you might have seen me on YouTube. I'm also a podcast host on Command Shift Left. So if you haven't listened to the podcast, I highly encourage you to do so. For engineers meetup, we chat facts. It's fun. It's entertaining. Now, let's start this presentation, start this talk, by actually flying through the history of the web, because I think it's interesting. And once we go through the history of the web, we're going to highlight at each stage how we managed permissions and how we managed to control what people can and cannot do. And at a lot of these stages, well, we really couldn't control what people can and cannot do. First of all, we had the static era, HTML and the birth of the web. Now, this is where we really started to understand the web, started to understand the internet and website creation. And therefore, we managed to learn a few technologies here. We were able to use basic HTML. We were able to do a little bit of CSS, which was introduced a little bit later in the era, to give the websites a little bit more information and maybe a little bit of color. However, how did we manage the access control? Well, we are mostly reliant on server configurations. There was no dynamic content, no user-specific views. It was just plain HTML and not really much that we could do at that point. Everyone who came to the web page could see everything, and we couldn't really control much. But then later on, we had the rise of interactivity. Things like CGI, early server-side scripting, languages like PHP came into play, where we started to get a lot more control of what we can and cannot do. And therefore, we had these technologies, even an early introduction into MySQL databases. We could pull some data. And therefore, with these types of technologies, we could start designing basic login systems with PHP. We could start storing our basic users in a MySQL database. And so we could kind of handle that control a little bit better. But we had to write our own enforcements to make sure that the people that actually log in or the people that can do something within the application, well, how restricted are they? So it still wasn't where we wanted to be. And of course, well, that access control was primarily reliant on backend. So it was reliant on the PHP. It was reliant on the sessions and the cookies that we created. And well, it was just hard to still manage the users. There was still a lot of nitty-picky and gritty stuff that had to be done, which wasn't the most convenient for us developers. Then we had the rich internet come into play. So things like Flash and Ajax. Now, this is where it really started getting exciting, because we could start doing a lot of very fun things. And not just fun, but we could also control the amount of security we have within the applications. And play around a lot with things like Flash that allowed us to do Flash is mostly recalled for having the basic Flash games, but it also allowed us to do other very cool things in regards to security. Now, access control at that point, well, it was a mix of front-end and back-end. Because of Ajax and because of the front-end flexibility here, we were really able to kind of start controlling what we show to the user. But it still didn't have the right logic. It still didn't have the right implementation. It still wasn't robust enough. We couldn't get too granular with the checks and how we do things. And therefore, the dynamic content adjustments and things that we wanted to change, well, it still wasn't as good as we hoped it could be. And then came the age of single-page applications, modern JavaScript frameworks, things like Angular, React, Vue, advanced browser APIs. And this is what really kind of stood out to us. And this is kind of the revolution that we already went past, but things that really changed how we implement websites, how we build websites, and how we, in general, plan our applications, how we build things, and very most importantly, how we control the access control. So who has permissions to do what? Now, while the backend here, of course, ensures attaining all of these features. Of course, we had things like JSON Web Tokens come into play after we authenticated the user successfully to then manage that user a little bit further on, and therefore have that more granular access control. And then we have the future. We have the future of WebAssembly, things like serverless architectures, and so on and so forth. And the key technologies that come into play are WebAssembly, serverless functions, cloud-native tools. There's a lot of things that we can start doing to really bring the access control to a much more granular level. And therefore, our front end is strengthening, our back end is shifting to the cloud, and therefore we can become much more advanced with the front end methods that we have and the amount of cloud validation that we can do. Or what can we do apart from that? What can we do that's a little bit more unique? And this is kind of where Permit.io comes in. And I'll talk about this a little bit. Now, Permit.io is a full stack authorization as a service. And essentially, it's a no-code platform that allows you to control and manage who can do what within your application. It's essentially an access control studio that allows you to not write any code. So something that we're seeing that comes into play now, the no-code, low-code applications that allow developers to do things much more quickly and in a much more robust way. Now, understanding permissions in general is very difficult, but it's possible. You can start to understand different models that we apply, how we enforce the access to people. However, trying to solve permissions gets much, much more difficult. Now, in general, access control is very hard, and a lot of you might have struggled with it before, or a lot of you might have just implemented very basic authorization, things like giving a role to a user, and then that user can do A, B, C, but nothing else. That's what we call RBAC, so role-based access control. But permissions get much, much harder than that. And it's about what happens when we grow as a company. What happens when our requirements expand? How do we manage that? How do we solve for that? Where do we get the engineering power to be able to control all of it? It actually gets very, very complex. And it's something that a lot of people forget about. And it's something that's becoming very prominent in the space because security is so important. And we all know that as engineers, and we're all becoming more aware of it. So how do we handle security in the right way? Well, there's a few things in regards to why access control is hard. First of all, we moved from monolith to very complex microservice architectures. We're dealing with a lot of containers, and how do we manage the permissions for those? Well, that's another barrier that we have to face. Then there's many scenarios or use cases that need to be covered. Different departments reach out to us, and they ask us to implement some permissions, and we have to satisfy those. And that's one of those challenging solutions. Then, of course, any minor bug that we introduce, any little mistake that an engineer might make could really have devastating effects. Just one user that's not appropriate getting access to a specific folder with personal information, well, that can turn out to be extremely tragic for a company. And we really, really, really don't want that to happen. So in that case, what is the best way to implement permissions? How do we do that? Well, I want to tell you about a very typical use case of what really happens in companies nowadays and how engineers deal with it. Well, imagine you're an engineer. An engineer wakes up in the morning, 9 a.m., he goes into work, dreads going into work in the first place, and then his product manager speaks to him, and he's like, you know what? We need to implement some permissions. But we don't just need to implement one permission. We need to implement several permissions for the team. So we need several roles. So you go ahead and you create those roles, and you implement this, and you create a PR, and then your product manager gets back to you, and he's like, well, you know what? Suddenly our permissions, we need to be more granular. We can't just control a specific role and who has access to something. We might need to control his location, and can he access it from this location, the time that he accesses a specific file, for example, the reasons behind the way why he needs to access it. And therefore, the permissions become much more granular. So this engineer, he's grabbing his hair, he's pulling his hair out, and he's like, oh my God, how do I solve this? And he spends hours and hours writing the code. Now, we have to remember that writing permissions doesn't usually happen with just JavaScript code or any code that you're writing your application with. There are specific languages that you have to use, things like Rego or things like Cedar, because then those languages get converted to something that a policy engine understands. And the policy engine is the usual implementation of how you would enforce the permissions. The policy engine understands the rules you've written, it takes it, and it gives you back an answer saying, well, has this user been rejected or accepted to do that specific thing? Now, this engineer has to write this. He creates this PR. He does all these, all the things that he needs to do, and then he gets back to him, and he needs to write tests. And then the tests fail, and then his PR gets rejected, and he has to make changes, and then it finally gets approved, and then it works. Hopefully it works, but then something happens. And then he has to change something because there is a critical vulnerability. And he has to go through that process once again. And it takes so much engineering time, and it's just so complicated. And this is what the engineer looks like afterwards. He just wants to cry. So then we need to start thinking how we can make this better. What can we do to actually create and understand permissions in the front end and apply them in a much better way? Well, then we talk about something called policy as code. And policy as code is essentially separating and managing policies separately from our code base as code. So things as Rego code, Cedar code. This is the right implementation to do so. Now, there is a lot of benefits that come with policy as code. Things like us being able to decouple the policy from the code. So it's not coupled within our code. So then when we make changes into our code base, we don't have to deal with extra code that exists in there that manages who can do what. We have the increased flexibility because it's maybe in another repository. It's contained somewhere else. We can move it. We can adjust it very easily. Of course, we have improved performance of our applications rather than having another, hundreds of thousands lines of code that, talk about the permissions that we have. Well, it's not. We can just pull the permissions and store them as cache in the policy engines. Now, managing permissions with the front end, no backend. Now, a lot of you are probably reading this and you're like, well, what do you mean no backend? How can we manage permissions without checking them in the backend? Well, can we? Well, maybe you guys are thinking, well, maybe this is a really bad idea. Maybe, well, he shouldn't manage permissions in the front end. How can you do that? Is that the right thing to do? He must be crazy, is probably what you're thinking. And some of you might really get upset, like this GIF right here. But, well, maybe it's a bad idea, but maybe it's not. And I want to introduce you to something called policy as low and no code. Now, policy as low and no code is essentially a way of us being able to manage those policies without writing the very complex Rego or Cedar code that is essentially a very big learning curve for any engineer. And if you ask a new engineer to learn Rego or Cedar code, he won't be happy, let's say that, because it's just a very big learning curve that no engineer wants to do. It's also a very complex recursive language that no engineer wants to learn. So that's why we have policy as low code and no code. Now, previously, I showed you Permit. Now, Permit, like I said, is a no-code authorization as a service. And what they allow you to do, as you can see from the screenshot, is manage those policies as basically a table. You're able to create the roles. You're able to create the different resources that you're going to manage, the specific actions that you're going to be performing on those resources. And then you can assign these roles to the specific users that have currently logged in for your system. Now, in general, the flow works in the way that the user authenticates. They confirm their identity. They confirm who they claim to really be. And then they get issued a session and a JSON Web Token. Now, JSON Web Token contains a unique identity of that specific user. And that unique identity gets matched into Permit. And therefore, when you perform an authorization check, when you perform a guard or an enforcement point within your application level code, in your front-end code, well, you can actually check whether that user is who he claims to be. You can check the user's role. You can check if he can, for example, perform a specific task, and maybe if he can delete it. In this case, but just by looking at the table, he can't. And therefore, you can assume what he can and cannot do. And this is what the policy engine understands. Now, the beauty of these no-code tools for authorization is that you don't write the code. It just generates it for you. So it's an extremely big win for any engineering team, because suddenly authorization, which is such an incredibly hard subject, becomes extremely easy to implement. It's happened the same thing with authentication. A long time ago, like we were talking about the era, we were writing login systems with PHP, and you had to write it manually, and you had to test it, and you had to make sure it works in the right way. And of course, there was a lot of vulnerabilities, because you can't just think of everything. Engineers make mistakes. And it's, in this case, when dealing with things like that, it's extremely easy to make a mistake. And therefore, a lot of companies started building authentication solutions. Things like Auth0, Clerk.dev, SuperTokens, Keycloak, Okta. There's so many out there right now, and you can literally pick and choose the one you want. And they allow you to make sure and validate a user that's logging into the system. The same thing is happening with authorization. It's too difficult to write, and it's much better to outsource something that already exists, that you can use very easily, embed into any application, and it's just an extremely smooth process. Now, this is what an enforcement point with permit looks like. That unique identity that you get from the JSON Web Token, you pass into this permit check function. You pass in the action you're performing on the resource you're performing that action on. You can also have, for example, Filip at permit.io, and then you can have delete file, for example, and then that gets sent to the policy engine. And if the policy engine reads it, this gets converted into the Rego code, it checks the rules, and it replies, well, maybe John was permitted to do so, or he wasn't. Now, going back to the principle of enforcing permissions in the front end with no backend. What do you mean front-end-only authorization? Well, actually, FOAS is a really, really interesting feature within Permit. And what does FOAS do? Well, FOAS, actually, you guys might be thinking, well, what does FOAS do? Surely it's an oxymoron. How can you have front-end-only authorization? Well, what if you want to, for example, see a specific scenario? What if we want to create an API call, like a Stripe for performing payments? We have a user, and in the front end, we can take a payment from the front end without talking to the back end. What if we want to check and pull some data from the database directly from the front end? You're listening to this, and you're probably like, what is this guy talking about? What about if we want to send emails and control who can send emails directly from the front end? And as you can probably imagine, I could go on and on and on with these examples of the things that technically you shouldn't do from the front end. Well, actually, with FOAS, you can do that from the front end. Now, FOAS works in a very interesting way. It essentially proxies any API calls that it receives through Permit, now through the authorization solution. It firstly verifies the user's identity. It checks whoever that user has the permissions to perform this API call. So here you're placing a guard on a specific API call directly in the front end. And then we're adding the secrets that are necessary. And then further on, once we check that the user can do that, we proxy that and call the specific API endpoint that, for example, Stripe provides for us. Now, this is essentially what it looks like. You can see we have the front end. We do the protected API call. It goes through the FOAS proxy. We add and enforce permissions. We inject secrets. We reach the service, like Stripe, or in this case, AWS S3 buckets. We get a response from the policy engine. It hits us FOAS proxy, and then it hits back and gives us a response directly from the front end. And this could be, for example, a unique and specific and secret user data that we're getting back. Now, this is essentially another example of how it works, with a bit of the UI in the front end. We're trying to do some transfers. It goes through the proxy. We have a bunch of services that we can use, and it's looking at the policy that's defined right here. And as you can see, we can, as an accountant or an owner, these are the two roles. For a checking account, we have the specific permission. So an accountant cannot do a wire transfer, but an owner can in this case. And this is what the configuration of this actually looks like in the UI. You pass in the API endpoint that you want to call for that specific service. In this case, we're doing payments for Stripe. We mark it as a post request, and you can pick any type of request that you want. We pass in the resource. We pass in the resource that we're dealing with, which is payment in this case. We pass in the action that we're performing on this resource, any kind of secret configuration, and that's a Stripe proxy configured. And all you do is you just plug that into the front end as a permit check, and it just starts working out of the box. And therefore, you really don't need to configure any backend to do all of this. Now, if you want to read more about the FOAS proxy, you can actually look at it at this link, and you can follow this link along if you want to read along and actually see a whole example of the implementation. But then what about things like feature toggling? Well, feature toggling is another big part of maybe authorization. Imagine that suddenly you're registering for a Netflix account, right? And as part of this Netflix account, you're a free customer, so you only have access to maybe the free movies. Maybe you can't watch anything. Maybe you don't get access to the full selection of movies. Well, suddenly, as you become a paying customer, you get access to more movies, and you need to display that in the front end to the end user. And that's kind of where feature toggling comes in. But before you display that to the front user, you need to actually verify who that user is. Does he have the maybe paying role? Has he paid for the subscription? And therefore, only once you perform those checks, you can verify what the user can and cannot do, and if you should display part of the UI and change his user experience. Now, in general, doing things like this with policy engines, if you were to write the code yourself, is extremely hard. Because with every single policy engine out there right now, they have one really big, but really, really annoying limitation. And that limitation of all the policies that are currently available to you, the limitation is that they cannot drive and understand real-time updates. So if you wanted to push a feature, for example, like changing the payment subscription of a specific user, you'd have to have an engineer, manually write that code for you. And you can't do that. It's not manageable. What if you're dealing with millions of users like Netflix? There is no way that you have an engineer just changing everyone's permissions. So there is also, a specific, vulnerability of these policy engines, a limitation. And at Permit, we also wrote this open source project that allows you to drive these real-time updates to the policy engines, and it's called OPAL. You'll be able to find it online. I haven't actually included a link to this, but you'll be able to find it online. Now, in this case, of course, because of something like OPAL, because of something like this implementation, we're able to much better control feature toggling and how things are displayed to the user. So now I have another example for you, a very quick one, where we have a viewer role, for example, and we defined a bunch of resources here. Now, in this case, when we're working with feature toggling within Permit, the resources we are using are basically the UI components that we want to show to the user. So in this case, we're showing product configurations, products, project builder, topics for you, and we just have one action defined for it, and the action is view. Either you can view it or you can't view it. If you change your role, and if you, for example, rather than being a viewer, you kind of you're paying and you meet and you satisfy the paying condition, well, then your role changes to a paying viewer maybe. And then in this case, if you couldn't view products, in this case, you might be able to view. Now, based on this configuration, this is what the UI might look like. And this is just a very, very simple thing I've mocked up. Just you can see the specific tiles that are actually rendering to the screen. But suddenly, as you take away the permissions, so now as a viewer, I can't view product configurations. I can't view products. I can't view the project builder. I can only view topics for you. This is what the UI would therefore render us. And if you really want to kind of understand this and go deeper into it, well, therefore, you can actually follow this link. And I've written a beautiful guide taking you through exactly how to model feature flagging and how to model specific UI experiences based on permissions and who can access specific parts of the UI. Now, I think I've given you a lot of information in this talk. So I kind of want to wrap up and ask you, well, what is the moral of the story when it comes to managing permissions? Well, we have to realize that it's very, very easy for us to think that we can do permissions ourselves. And maybe it is. When you start creating basic permissions, you'll create basic roles, something like an admin. And an admin will be good enough. But suddenly your permissions will grow. And then you'll be like, well, OK, I need to add a super admin role now, because I need more flexibility with how I manage my application. And a super admin role will work, but then suddenly your requirements will grow, and suddenly you will need 5 more roles. And then not just only roles, not just roles that allow you to do basic role-based access control. You might have to face and write policy models for something like ABAC, so attribute-based access control, which means that you're not just checking for a specific role. Maybe you're checking for an admin that's located in continental US and can only read a document between 9 and 5 p.m. Suddenly, it's getting much more complicated. And then your requirements grow even more. And you still think maybe that you can write this, and realistically, let me be honest with you, you cannot. Things like REBAC, so relationship-based access control. So suddenly you have to write something like a graph, essentially, of nodes and edges, nodes being the resources you can access, edges of how those resources cascade permissions to one another. And suddenly, based on the relationships you have in your modeling, you might have a user who's part of this admin group, and everyone inside of this admin group can access this specific document, and everyone who can access this specific document can then access something else. And you get this whole hierarchy. And then it gets even more complicated, because what if you need to combine REBAC with ABAC and specific need conditions? What if you need timed access? And it all gets very, very complicated. And then suddenly you're left with no hair on your head because you've pulled it all out. So the moral of the story is, make sure that if you do decide to write your own permissions, and it's something that you're thinking about, which is becoming the fundamental part of any application you write these days, well, make sure that you actually outsource and use something that's already available to you, rather than writing it on your own, because in the long run, you're going to end up regretting it and using something that's already pre-written in the very end anyway. So thank you very much for watching, guys. My name, as you can see, is Filip Grebowski. You can find me at Developer Philip. You can also join our Slack community if you want to learn more about authorization. And if you'd like to check out permit.io, you can check it out at permit.io, as the name says it. Thank you very much.
Yes. Hey. Hi, Philip. Thanks for the talk. And
Hey,
yeah, wait. Can you hear me?
I can hear you. Yeah, I'm
Yes.
ready
Yeah,
for
perfect.
questions if anyone has any.
Yes. We have quite a few actually.
Amazing.
So the first
I
one
like to
is,
hear.
could you go over a few ways that Hanko differs from Permit.io?
Yeah, so Hanko is an authentication solution. So a lot of authentication providers nowadays, they provide you with basic authorization. So they'll provide you with basic role management, maybe setting up a few roles and doing very, very minor access controls. So maybe an admin can read this document and a viewer can only view this specific document, whereas Permit.io has nothing to do with authentication. We're fully authorization driven. So we just give you a platform just to handle your policies, just to generate your policies, generate all the complex code, and just give you very, very simple ways to plug this into your app and plug this into any authentication provider that you might be using. At the end of the day, all authentication providers, they should, and they must at this point, provide you with a JSON Web Token. And therefore, if you can extract the unique identity from the JSON Web Token, you can seamlessly integrate into Permit.
Yeah. Yeah, also I can understand the confusion between authentication and authorization.
A lot of people do. It's probably because the two words sound very similar.
Exactly. You just end up at Auth and then...
yes.
Yeah.
Which one?
Yeah, exactly. Do you recommend implementing those robust authorization solutions early, or should they be implemented once it becomes more complex?
Really good question. I think if you're planning an application, you should always, at this point, consider authorization. It just becomes a fundamental thing as part of building an app. It's one of those main building blocks. We think about logging a user in. We think about getting the right database. We think about the right hosting and deployment. We think about putting things in containers. And authorization should just be one of those main building blocks. So the sooner you can do it, the less problems you're going to have in the future. Luckily, in some scenarios, because a lot of people, when they do write authorization, they work with these generic languages, you can very easily kind of plug these languages back into Permit, and they should kind of start working seamlessly. Sometimes you have to model everything that you have. And from my experience, a lot of the companies that we end up working with, they actually find it they actually struggle modeling their own authorization even after they've written everything themselves, because they're not really aware of it. It's so complex. So it's better to avoid that complexity, avoid that problem, and just if you can do it sooner, the better. If you can't, there's always ways to easily plug it, but it just produces much more developer efforts than you really need. And essentially, you're wasting developer time rather than focusing on the thing that should be really important when you're developing your project.
Exactly, things that matter again. Yeah.
Yes.
I totally agree with that. I'm even like a prone of saying, hey, like when you build an app, don't wait until the end to like try to deploy it. Deploy it from the first line of code. That way you have the pipeline set up.
Exactly.
You can fix bugs. So yeah, exactly the same way.
Exactly.
And also, like if you're using Vue.js, you're probably having a app, not like a static website. Otherwise, you would use I don't know, like Astro or something like that. So yeah, it doesn't make sense. Like if you have an SPA or something dynamic. Yeah.
Absolutely.
What solutions are available for working with Permit.io or Hanko in the various frameworks like Vue, React, Angular?
So essentially, Permit just plugs into anything. You can be using React, Angular, Vue, Django. It really doesn't matter what kind of framework you use. Essentially, we support pretty much everything. If you're not using Permit in the no-code UI, which some people would just decide not to do, everything is fully API driven, so you can manage everything through the API. And if your framework works with an API, which pretty much all of them do, you can just very seamlessly do it. The idea here is that we produce as little barriers as possible for people to actually work with authorization. It's difficult in the first place. Why make it even more difficult? So I think whatever you're working with now, I'm sure you're not going to have any problems working with Permit, or actually even working with any authentication solution out there. Even the other authentication solutions that manage the confirming the user's identity, they also provide a bunch of different frameworks and libraries that allow you to kind of very easily integrate it in the first place. So whatever it is, Permit or any other authentication solutions, or even authorization solutions, I think most of them have a simple way in.
Yeah. I even saw that there is like a passkey API for this.
For what?
Like a passkey API for the authentication part.
Yeah, well, there's so many things actually. It's
So that's perfect, because I was looking for a specific solution for one of my side projects. So perfect timing for the
yeah, perfect time.
talk.
Yeah, it's really you won't have any problems. I can guarantee that.
And also, like most of them, yeah, as you said, have like standards nowadays, so that you consume it the same way, and it's kind of like the same usage. So
Yes, and standards are actually extremely important here, especially when authentication authorization works together, because the closer the standards are, which they are at this moment, really you're working with a JSON Web Token most of the time, and you take that from beginning to end. Well, essentially, we called all of this the handoff point. As soon as the user logs in, you verify his identity, you take that unique ID, you sync it into permit, you assign the user a role, and then you render the UI to the user. So you go through this whole handoff point of verifying and giving access before the user even accesses the website. And that's kind of the usual way you want to take it forward.
Yeah. Do you think that this raises the overall security of the apps by delegating this step to someone rather than trying to implement your own?
Absolutely. I mean, with any authentication authorization solution, everyone is very.
Wait, I think Filip is cutting a bit. Hey, do you hear us?
Reports and security questionnaires,
Cutting a bit.
all of that. Also, did you hear me or did you lose me?
Yeah, now you're catching up, I guess.
No, I'm catching up. Okay, so there's a lot of kind of security that goes into these companies that these companies are aware of. And if you're writing this on your own, you're just going to probably end up missing that, or you're going to just end up again spending way too much time trying to figure it out rather than actually focusing on the main important thing that you're trying to build.
Yeah. Okay. Related to that, is there a free tier or playground for permit?
Yes, absolutely. So Permit has a very extensive free tier. So up to 1,000 monthly active users. So up to 1,000 people with a unique identity. Essentially, Permit is free. We don't limit you on any features, even though it might say on the website that we do. We actually really, in reality, we don't. You have access to absolutely everything for free. And only if you need things like SSO, or you need like an enterprise tier where you're really starting to work with large numbers of users, then you talk to us. But other than that, for setting up a POC, for doing a side project, it's free. You won't even have to think about it.
Yeah, I mean, at this point also makes sense, because if you're making money out of the service, yeah, you can probably pay a few fee for that. Yeah, I agree.
Exactly.
Yeah, perfect. Nice to meet you, and thanks again for the talk. That was very insightful. And,
thank you very much,
see you
guys.
very soon.
Yeah, thank you, guys. I appreciate it to be here. Enjoy the conference, and I'll see you on the internet.
Yes.
Bye-bye.